Hello student, today I am going to derive the polar equation of tangent and normals of a conic. Now before that let me just recall the polar equation of a chord PQ whose vectorial angles are alpha and beta respectively. That means if I take S to be the focus we consider it as a pole, then what is PS? PS will be equal to R1 and the angle made by PS with respect to the initial line, this is the initial line, is alpha, and cubed s is equal to r2, and the vectorial angle made by this cubed s with respect to the initial line is beta, then the equation of the polar of the chord pq, this one, will be given by the formula L by R is equal to E cos theta plus B plus secant beta minus alpha by 2 cos of theta minus alpha plus beta by 2. Now how will you get equation of the tangent from this equation of the chord? Now, in order to get, as we know from the definition of tangent, tangent is nothing but it is a straight line which touch the given curve at a given point only, at one point only. So now, in order that this chord PQ becomes a chord or become a tangent, then this point Q must coincide with point P. So for that, this beta should be equal to alpha. So to get the equation of the tangent from this equation star, that is equation of the chord PQ, you just have to replace the value of beta by alpha. That means point Q will coincide with point Q. With point P. Now equation of a tangent at P is given by, that is, this point Q will coincide with point P. So now it's given by L by R is equal to E cos theta plus secant. Now replace this one, because if point Q coincide with point P, then in that case beta will be same as alpha. So you replace beta by alpha, then you will get alpha minus alpha by 2 cos of theta minus alpha plus alpha by 2. So this will be the equation of that tangent at P, where Q coincide with P. So now simplify this one, you'll get L by R is equal to E cos theta plus secant 0. Secant 0 is same as 1 by cos 0, but cos 0 is equal to 1, so this will give you 1 into cos of theta minus 2 alpha by 2. 2 get cancelled. So this gives you L by R is equal to E cos theta plus cos of theta minus alpha. So this is the equation of the tangent at point P, whose vectorial angle is alpha and R is a distance from P to S, that is a focus or the pole. So now the equation of the tangent at point P, whose vectorial angle is alpha, now will be given by the formula L by R is equal to E cos theta plus cos of theta minus alpha. So you can see that you can derive the equation of the tangent from the equation of the chord by letting Q coincide with point P, that is by letting R2 tends to R1 and beta tends to alpha. So this will give you the equation of the tangent. Now what do you mean by normal? Normal is nothing but it is a line which is perpendicular to the tangent at that point of contact of the tangent. So in this case, this will be the normal. So we have to find out what will be the equation of this normal here. From this equation of tangent, we can derive the equation of the normal. Now let us recall this one. We know that ax plus by is equal to 1 represent the equation of the line in Cartesian form. And the equation of the line which is perpendicular to this one will be given by the formula bx minus ay is equal to k. So now here where k is a constant to be determined. So now in Cartesian form, ax plus by is equal to 1 represent a line, and bx minus ay is equal to k will represent a line which is perpendicular to this one. Similarly, in the case of polar form, we know that L by R is equal to A cos theta plus B sin theta represent the equation of a straight line in polar coordinate. Then the equation of a straight line perpendicular to this one will be given by the formula KL by R is equal to minus A sin theta plus B cos theta. So this is the equation of the line which is perpendicular to this line. So now here we have it as minus A sin theta plus B cos theta. But I can express this one as, what is minus sin theta? It can be written as cos of theta plus pi by 2 plus, Now to get this one sine theta here, it will be same as sine of theta plus pi by 2, because if you expand this one to form sine A plus B, then you'll get cos theta, and here also if you expand this one which is of the form cos A plus B, then you'll get sine theta. So therefore this equation KL by R is equal to A cos of theta plus pi by 2 plus B sine of theta plus pi by 2 is a line which is perpendicular to this line. L by R is equal to A cos theta plus B sine theta. So if you compare these two, what we see is that the angle here in the line which is perpendicular to this one, the theta here has been replaced by theta plus pi by 2. So, and also here on the left hand side, it is a multiple of k times of whatever be the term on the right hand side of this equation of the line in polar form. So KL by R is equal to A cos theta plus pi by 2 plus B sin theta plus pi by 2 represent a line which is perpendicular to this line. But here in our case, we are interested in the equation of the line which is perpendicular to this tangent. So if you see this represent the equation of the tangent and compare it with this one, then you see that the equation of the line which is perpendicular to this one will be what? It will be k times of L by R is equal to E cos of, but theta has to be replaced by what? Theta plus pi by 2. So let us find out what will be the equation of the, now equation of a line perpendicular to the tangent L by R is equal to E cos theta plus cos of theta minus alpha will be what? It will be k times L by R is equal to E cos of what? Now here for the line to be perpendicular to this one, we have to replace theta by theta plus pi by 2. So it will be cos of theta plus pi by 2 plus cos of theta plus pi by 2 minus alpha. So this is the equation of the line which is perpendicular to this tangent of the tangent to the conic in polar form. So now let us find out what is this k. But we know that point P, this one, point P whose vectorial angle is alpha, lies on the conic. So therefore we can replace this one. You put since P R alpha lies on the tangent, because this point of contact of the tangent, it is a point which is common to the conic and the tangent. So lies on the tangent. So in that case, you put theta is equal to alpha in this equation star. In star, we get L by R is equal to E cos alpha plus cos of alpha minus alpha. Replace theta by alpha here. So this will be equal to E cos alpha plus cos of 0 will be 1. So L by R is equal to 1 plus E cos alpha. So we have L by R is equal to this one. From here you will find out what will be the value of R. R will be equal to L by cross multiply this one to this side. It will be 1 plus E cos alpha. So you know the value of R and you know the value of theta to be alpha. You substitute it in this equation. That is this equation. Let me denote it by equation double star. Now putting theta is equal to alpha and R is equal to L by 1 plus E cos alpha in equation double star. That is in the equation which is perpendicular to the tangent. So if you put this one, then you'll get double star now will implies you KL divided, what is R? R is this one, L by 1 plus E cos alpha is equal to E cos of, replace theta by alpha. So you'll get it as cos of alpha plus pi by 2 plus cos of alpha plus pi by 2 minus alpha. This one, replace theta by alpha, so it will become alpha plus pi by 2 minus alpha. Now alpha, this alpha and this alpha here will be cancelled, so you'll get cos pi by 2. But what is cos of pi by 2? It will be 0. So let us simplify this one and see then what will be the equation. So this implies that LL, now L and L can be cancelled. This one will come to the numerator. So k times of 1 plus e cos alpha is equal to, what is cos of alpha plus pi by 2? Cos of alpha plus pi by 2, it is same as minus sine of alpha. So therefore it will become minus e sine of alpha. So, and this term will vanish because cos of pi by 2 is equal to 0. So finally it reduces to this equation, and this implies that k is equal to minus e sine alpha divided by 1 plus e cos alpha. Now substituting this one, value of k, this one, the value of k is equal to this, putting the value of k in equation double star. That is in the equation of the line which is, this is equation double star, which is an equation perpendicular to the tangent at point P whose vectorial angle is alpha. So putting the value of k in double star, we have minus e sine alpha by 1 plus e cos alpha into, because it is k times of L by R, so it will be L by R, that double star. This is equal to e cos, cos of theta plus pi by 2 is same as minus e sine theta. So it will be minus e sine theta plus, and then here it will be cos of theta plus pi by 2 minus alpha is same as minus, it will be minus sine of theta minus alpha. Will be minus sine of theta minus alpha. You just replace back this one by, you expand this one, then you'll get that cos of theta plus pi by 2 minus alpha is same as minus sine of theta minus alpha. So now here you see that minus sign can be cancelled throughout. So you'll get it as e sine alpha by 1 plus e cos alpha into L by R is equal to e sine theta plus sine of theta minus alpha, or L by R into this one e sine alpha by 1 plus e cos alpha is equal to e sine theta plus sine of theta minus alpha. So this is the required equation of the normal, which is a line perpendicular to the tangent at the point of contact of tangent, that is at this point P. Hope it is clear how we are calculating, how we derive the equation of the tangent from the equation of the chord of a conic in polar form, and from the equation of the tangent we can derive the equation of the normal using the condition that in polar form, if L by R is equal to A cos theta plus B sin theta represent the equation of straight line, then the equation of the straight line perpendicular to it will be given by the formula KL by R is equal to minus A sin theta plus B cos theta. So with the help of this one, we can derive the equation of the normal to the tangent as L by R is equal to E sin alpha by 1 plus E cos alpha is equal to E sin theta plus sin of theta minus alpha.